Electrostatics 18. We'll continue with the exercise and problems. And you're supposed to have that list of formulas I've given you yesterday with you. Huh? Look, you should be able to recollect the formulas, not me. Slowly you should get to that mood. For all these days we've been doing the lesson, doing examples, and then summarized it later in the form of mathematics. So those list of formulae should be there by your side, and read the question, try to visualize it in a physical sense, and try to recollect the idea and try to connect some formula to it. So that whole process should keep happening. And in the middle, of course, I'll give you a little help. But if you think like anyway the problems are all over, I mean the discussion is all over, some problems are all over, so it's sir's job to do everything and then you'll copy it and repeat it later. No, it won't work. But let me now come to the questions. I want you to speak. No, if you don't speak, actually the lesson suffers. You don't know. These are two infinitely long plates I have, or long sheets of charge I have. One here, another here, facing each other actually. The drawing will be slightly difficult, but I'll try. I mean, you should understand that they are facing each other. Okay. This is a negative charge. Hello. Yeah. You be on time. Once I start, I'm not going to allow you. Plus sigma minus sigma like this. This cross thing, all this I put only to tell you that they're infinitely long sheets. Huh? Infinitely long sheets of charge. Okay, I'll give you points like this. Some point P here, point Q here, point R here. At P, Q, and R, find out E. So it's not a difficult question, children. So even if it is going to be wrong, say something.
Sir, it will be sigma by 2 epsilon.
That formula to be used, you mean to say?
Yes, sir.
Okay, let us use that formula. At Q I am writing. So how should I write? It is a superposition once again. EF this at different points you should write. EF this plate at Q will be away from it because there's a positive charge. So sigma 2 epsilon 0. This is only because of this one. Huh?
And for the negatively charged plate, it will be towards it.
Towards negative. Sigma by
2 epsilon.
So the net is how much? Isn't it?
Yes, sir.
In towards minus. All right?
Yes, sir.
Oh, this is the first answer. At Q, at P.
At P, it will be sigma by 2 epsilon away from it.
Due to plus
Due
charge,
to
positive.
what, sir?
Due to plus charge, positive charge.
Yes.
Due to minus, towards minus, right?
Yes, sir.
So E at P will be 0. Tell me.
Yes, sir.
Two equal vectors in opposite direction. At R, E due to plus will be away, due to minus will be towards. So there will be field only in the middle, not this side and that side. So what are your thoughts on it?
Understood, sir.
Okay. Then in which case you can check this out. This is plus 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 like this, plus plus like this, plus sigma this sigma. So in the middle Q, outside P, outside R, write down EP equals how much, EQ equals how much, ER equals how much.
For EP is a sigma epsilon naught. Sigma by epsilon naught.
Okay.
EP.
EP will be sigma by epsilon. Which way?
Sir, right side.
Right side.
Left side, left side, left side. Left side, sir.
This side.
Yes, sir.
Then similarly, E at Q.
0.
0. E at R.
Sigma by epsilon naught.
Which way?
Right side, sir.
Right side. Done? So that's the second question.
Completed, sir.
Can we continue?
Yes, sir.
Lambda, lambda, lambda. E at O. This side is A, A, A. You need to make an effort.
Sir, we can use the formula 2k lambda by y into sine theta.
Look, just remember this formula. This is theta naught. This is theta naught. What do we write there? If it is positive charge, field is away from it, right? How much was that, Bharat? This only?
Sine theta, sir.
So
sine theta naught.
Yeah. Apply and tell me. But remember, both must be theta naughts. Then I can use this. And now, final answer you tell me. And I will check whether it is right or wrong. Why are you waiting so long?
Sir, is answer 0, sir?
Looks like that, but I want you to explain it. I'll draw the figure again for you. So, ask people to go out of your room, otherwise you have to mute your audio. So, due to this, see our angle is here, right, Bharat? Huh?
Yes, sir.
So, how much is this angle? 60. Now, E due to this will be this way, right?
Yes, sir.
Write that E. Don't guess that to be 0. It may be 0 because it looks like the symmetry sometimes helps us. How much is this value now? Tell me. 2k lambda by this is y. Since all are going to be same, even if you don't find y, it's not a big deal. Sine 60 I should write. So 2k lambda by y root 3 by 2. Y also you can get if you want. But maybe not so important because you know this is a by root 3. This is a by 2. You can also get this value. That's not a big deal. But look, because of the other one, it will belong this. Because of this one, it will belong this. All are equal and make 120 with each other. Therefore, E is 0 again. Okay? Tell me.
Yes, sir.
Yes, sir.
Now, one more I'll give you. The semicircle children, lambda is a charge density, but lambda is not constant. Lambda 0 sine theta. What is theta here? This one. At O, what will be E? So you ask me and you guide me as to what to write. Let us do mistake and get it, whatever. Just write. So if you've taken the question, I'll go to the next screen, children.
Yes, sir. We have taken the question.
Now, instead of waiting for me to spoon feed you, just try something. Let it be wrong.
Sir, is it 2k lambda by r, sir?
Bharat, this is what I really don't like with you. Just you don't give
Sir.
a respect to the question. They say something without even doing. Bharat, that this has been
Yes, sir.
your method, children, child. I want you to start learning. You are just making it what you call look like a farce. Huh? I was asking you, tell me how to do it. Some answer you gave. I'm not even interested in knowing.
Okay, sir. Understood, sir.
Tell me, what should I do? You tell me.
Sir, extended segment, sir, will get theta, sir.
See.
Take small element d theta.
Now, you want to take theta from here? You can. Right there, like this. So this is dq. Why don't you follow the method, Bharat?
Okay, sir.
Now tell me, that is dq. Length of this is
Yes,
how
sir.
much?
RD theta.
Rd theta. Now dq is e. You tell me where, how to put.
Sir, we have to extend it, sir. So we'll get a D cos theta and D sin theta.
Extend. I'm asking something. You're saying something. I'm asking you how d. First of all, should I tell you all this? Which already so many problems are over already. Don't say extend it like that. Put say de will be radially away from it. You're
Okay, sir.
simply catching the patterns, no physics in it. So what should I do now? This dq is a positive charge, so for a positive plus q, e at a point will be away from it. Why don't you listen? That you should put here. Then after that,
Okay, sir. Sir, we will get into D sin theta and D cos theta. Sir.
where is d sin theta? Where is d cos theta?
D sin theta is downwards, sir. D cos theta is rightwards.
This is theta, so this is theta. You mean to say? Huh?
Yes.
This will be d. This will be d.
Sin theta.
Okay, agreed. Just a minute. de sin theta, right? This is d.
Cos theta.
All right. So after this, what should I do?
Sir, because symmetrically they will be equal, sir, opposite to each other. D cos theta will get cancelled. And
D
there is
cos theta. This is cos theta. I'm sorry.
E will be equals to integral D sin theta.
But here lambda, remember, lambda is not constant. Okay.
Okay, sir.
So can I say the symmetrically opposite elements will cancel?
No,
No,
sir.
sir. You have to do for only one element.
We'll see anyway. That means you can think that this is there, that is there, and do both of them. But remember, though lambda is lambda 0 sin theta is a symmetric function. So still you can show that this component will be 0. We'll see slowly. So now what shall I do after this?
Sir, D is K dq by R square.
Okay, k dq by capital
R
R
square.
sine.
dq equals to
Ask your
lambda.
people to just leave the room. Tell them.
Okay, sir.
Now tell me, what should I do now? K dq. Bharat, come back. Abhinav, tell me, what is dq?
Lambda r d theta, sir.
Lambda r d theta sine theta by r square. I cannot take lambda out, Abhinav, isn't it? K lambda is lambda 0
Sin theta
r d theta once again
into sin theta
by r square. So one r goes. Now k lambda naught is a constant. K lambda by r comes out, right? K lambda by r comes out. This is sine theta. Sine theta. What should I get? Is it okay? Tell me.
Yes, sir.
And what are the limits?
0 to pi.
So how to calculate this? You tell me now. Integral sine square theta. How? Write it as two terms. If you don't know integral sine square theta integration, you may not be knowing. But
Sir,
can you not
integral sine square theta is theta by 2 minus sine theta by 2.
integration you are telling, or sin square theta formula you are telling?
Integration, sir.
How much is that?
Theta by 2 minus sine theta. 1 second, sir.
First tell me the formula for sin square theta in terms of cost, then we'll write that. Maybe it. You can't give the answer directly. Sin square theta can be written as what?
1 minus cos square theta.
1 minus cos square theta. What is the use? If you write like this, once again square will come.
Yes, sir. We will write cos square theta is 1 plus. 1 second. Sir, cos 2 theta plus 1 by 2, sir. Cos square theta.
Sin square theta can be written as 1 minus cos
2 theta by 2.
Can you write like that or not?
Yes, sir.
Tell me that. So let me write k lambda naught by r integral. What should I write? 1 minus cos 2 theta by 2 d theta. Right? So k lambda by r into, if you want in more details, you should write d theta by 2 minus cos 2 theta by 2 d theta. Isn't it? 0 to pi, 0 to pi. So k lambda naught by r. Tell me, d theta by 2 is theta by 2.
Theta by 2.
With pi minus 0. Can you write one step because my space is over? Theta by 2. So pi 5, substitute pi by 2 minus 0. So can I write just simply pi by 2 here? Huh? Tell me.
Minus sine theta by 4.
Here, what should I write? 2
Sine
comes out, 1
2 theta by 4.
1 by 4 sine 2 theta. Right? So sine 2 theta substitution if you do, sine 2 theta 0 to pi. 0 sine 2 theta pi sine 2 pi and sine 0 into
0,
what?
sir.
0.
Total is 0.
So what do I get now?
K lambda pi by 2r.
So if I write k equals 1 by 4 pi epsilon 0, check that carefully.
Finish, sir.
Now tell me about the other component.
Sir, Ex equals to integral d cos theta.
Yeah. That integration, does it come 0 or not? Check for a while. I'll give you time. I'll still discuss it. We are discussing it only in a mathematical way here. So I'll just go for a little physics approach there. But check whether this x component is becoming 0 or not. Don't tell me just 0 without doing. Do it.
Sir, no, sir, it's not 0, sir.
What do you say? Others?
Sir, it's not 0.
Bharat is saying it's not 0. How about others? Abhinav, Parashara, Rishita. Probably I need to go for the next slide to write it.
No, sir, it is not 0.
Abhinav? Abhinav, it's not 0.
We are getting same answer, sir.
Same answer. Let us check.
Lambda naught by 8 epsilon naught r.
Let me check. I'll just remember what is that? D cos theta, right? So Ex, that is, of course, in the opposite negative direction. Integral D cos theta is what we were doing, right? Isn't it so? Tell me. So
Yes, sir.
now, what is D? At one step we write K lambda dq. Sorry, K dq by r square
Cos theta.
cos theta. I wanted to write in one step, but you are not telling me. So K by r square lambda dx, that is lambda naught sine theta r d theta into cos theta. Isn't it so? dq is lambda dx, dl, whatever here. So lambda into r d theta. Lambda into r d theta. But lambda is lambda 0 sine theta. So one r going, what do I get? K lambda by r sine theta cos theta. I'll write
Sine 2 theta by 2.
So K lambda by 2r 1 by 2 minus cos 2 theta between 0 to pi. Tell me, children. Is the calculation right everywhere? So what should I write? K lambda by 4r into cos 2 pi
1, sir.
minus, so So what is
Sir,
happening?
it is 0 only, sir.
0, sir, it is.
Huh?
0, sir.
Tell me, cos 2 pi is how much?
-1.
So a lambda naught by 4r into minus 1.
-1 plus 1.
So it is 0. Okay.
Yes, sir.
So you have to get it by proof all the time. But otherwise, I was asking you the physics way of looking at it. What does it mean? I'll show you. Look, we have the semicircle like that. This is theta. So lambda equals lambda 0 sine theta when you mention. What do you mean by that in a physical sense, children? Look, sine theta 0 to 90 is positive, right?
Yes, sir.
Yes, sir.
So this charge will be positive, though not uniform. This overall charge will be positive here, right?
Yes, sir.
Yes, sir.
So the distribution is something. And later also positive or negative? Is positive again. Isn't it so? Even this side. But the distribution is different. But remember, whatever charge is there will be here. Whatever charge is there will be here. So it is symmetric about this y-axis. So charges are not uniform. For every dq here, there is a similar dq there. For every dq1 there, there is a similar dq1 here. Like that, it's possible that this component becomes 0 and this component may be read up. Do you really follow this?
Yes, sir.
Follow that, I'll give you another question. Try to do it in a proper way. Whichever way you have no problem with that, but let me see. Now I have got a ring. Now, if ring had a uniform charge, what would be the E at center, children? This ring
0,
had
sir.
0.
0, sir.
But now remember this theta, lambda here is not constant, lambda 0 sine theta. Find E at O. Next question, that is whatever number you give it here, give it. I don't remember the number there. There's one more question, come on. Slowly but with proper meaning you try. You understood what I was trying to tell you here? The thetas are not going to be uniform, but sine being a symmetric curve like that, for every dq here there will be one similar dq there. You're not saying anything.
Hello, sir.
Yes?
Sir, I have a doubt, sir. Sir, in this previous case, we took similar lambda, na, sir.
What similar? Same lambda. Previously same lambda. Now lambda
It is
is
semicircle,
changing.
na, sir. It is semicircle, na, sir. Previous case. Here, circle means 2 semicircles, na, sir.
Yes.
One resultant is down, another resultant is up. Won't they get cancelled, sir?
Tell me now. You only tell me.
Sir, is answer 0, sir, again.
The answer is
0.
0 according to Sai Bharat. Is it correct? No. Now I've given you a suggestion also. You did not catch. Look. Now this will be positive charge. but not uniform charge. Okay, remember it. So because of this, we had a field how much? Lambda by, just tell me the old answer. 8 epsilon 0 r, right? Huh?
Yes, sir. Lambda naught by 8
Now
epsilon
it is
0
all
r.
minus. Sin theta positive here, but minus in the third and fourth quadrants, right? So
Yes,
even
sir.
because of that, it will be same,
Downwards.
but downwards. That is lambda by 8.
Epsilon naught r.
That means it is lambda by,
4 epsilon naught r.
that's why the question is given.
Understood, sir.
How about others?
Sir,
Others.
practically, sir,
Huh?
it is practically possible to keep for a sphere like that, sir. It's half of this side positive and half of this side negative.
Why can't it be possible? Tell me. It is possible if it is a non-conductor. Huh? Do you follow? Even for
Yes,
conductor
sir.
also I could do that by applying this and putting this in electric field, external electric field, I can make it possible. Okay. Children, tell me. Anshuman and
Sir,
Abhinav. Anshuman and Abhinav.
Sir, for this full circle, then it will be 0, no, sir.
Are
For
Amma.
this full ring,
Uh,
electric field will be 0, no, sir.
if lambda is constant. Lambda
Not
is,
constant also, it will be 0, no, sir.
what child? I've discussed it so much and you are saying 0 just like that. Huh? I was talking
sir,
to Bharat and we were discussing it. No, you're not listening.
sir,
Huh?
if it is total plus means it will be 0, no, sir.
It will be
The
total
charge is
plus
total
0
positive.
already proved, but that is constant. Lambda is everywhere same. Charge per unit length is same everywhere. That's it 0. We did it already, right? Long ago, we wrote a formula kqx by
Yes,
x
sir.
square plus r squared for 3 by 2 on the axis, and at the center x equals 0. Therefore, at the center it is 0. We talked already. So no, nothing new in that.
Sir, because it is not constant, it varies,
Not
no,
only
sir,
not
charge.
constant, it's not constant, but it's changing as a sign function. That means top half is plus, bottom half is minus. In other words, what I mean to say is all this calculation you can do again, but the limits will be from 0 to 2 pi. You understand this ex, ey, which you did previously, integrate between 0 to 2 pi.
Oh, understood, sir.
ఇప్పుడు బుర్ర వెలిగింది అన్నమాట. Good. So without
Yes,
doing,
sir.
we are taking the help of the previous problem. For positive half, it is down so much, like we did. For negative half, it is down once again. So it is lambda by 4 pi epsilon 0. This is the answer for this question only, Rishita.
Yes, sir. Understood, sir, now.
So children, tell me others, Parashara and Pati.
Sir,
Hmm.
followed, sir.
Then I'll check your understanding with one more. Actually, it's unending. Somewhere you should say this type of
Okay,
problems
sir.
we are comfortable, but I'm not convinced. Let me see.
Okay, sir.
I'll give one more question, right? Next. Once again, half ring I'll take.
So this time take total negative, sir.
This is theta. Huh? Array negative. I'm giving you lambda equals lambda 0 cos 2 theta. Come on. Find out E at. Oh, so tell me.
Sir, 1 second, sir. Still doing.
You can follow the maths. Now you know little integration, just follow the maths. Come on, children. What are you doing?
Yes, sir.
Rishita?
Yes, sir.
So if you're doing all right, otherwise tell me, we'll do together.
Sir, I'm getting infinity, sir, again.
You have to improve your what you call accuracy, Bharat. How did you develop this habit of being very loose and slack? Tell me. You're having a habit of showing the answer first in the class and get praise in the school.
I don't at all open my mouth, sir.
Really?
Really, sir.
Are you talking so much? I was happy about you talking first.
Sir, you said you gave the freedom, sir. That's why.
Why not? That's my job. You are the most vocal fellow in the class, no? So I don't believe that you're not talking in your classes late there.
Sir, really not, sir.
Really?
Sir, starting also I thought not to talk, sir. But again, you said if you
No,
have
no,
doubt, you can
no.
clarify.
That will be my extra contribution to make you talk, which will be useful later for you. Remember it. That's meaningless not to talk. Why? What is the use of teachers then?
Sir,
Tell me, children. I was just sending
sir,
messages.
here
Huh?
in the middle, I got cos cube theta somewhere. I don't know how to integrate that.
Let us see. Let us.
Sir, sir, I took cos 2 theta, sin theta, sir.
Don't tell me like this. It's not that I mugged up any question. I just gave it. Now it's let us do
Okay,
it.
sir. Okay, sir.
Let us do it. But one thing, children, can I make a guess here about the charge distribution?
Yes, sir.
Yes, sir.
Tell me, children, what kind of a guess I can make?
Sir, EX will be 0, sir.
Charge
EX will be 0.
ఎంత భరత్ అట్లా మాట్లాడితే నేను అనేది చార్జ్ డిస్ట్రిబ్యూషన్ గెస్ చేయగలరా
Sir,
అంటే
half quadrant will be positive and half will be negative.
that's what Rishita was understanding, which means I can do for only quarter and get my answer in a simple way. That's how you can cut down
Okay,
the
sir.
calculation. Tell me, Rishita, why half is positive, half is negative?
Because cos in first quadrant is positive and cos theta in second quadrant is negative.
Okay. Why am I telling you? If I do this, I can just only take this quarter. If it is for this quarter thing, it will be somewhat like this or like that. For negative, it will be the same direction. I can double it. Do you follow, children?
Yes, sir.
Do you follow? Tell me. So what do I
Yes,
do?
sir.
I'll take one r d theta element here. dE will be like this. Isn't it so? So if I said this was theta, this would be theta, children. Huh? So d cos theta, d sin theta as usual. Huh? Do you follow? D.
Yes, sir.
But there will be d cos theta also here. Of course, this you could have, for two things, we could have ignored this, because if I took a minus thing, what will happen? So which will cancel now? You tell me.
Sir, how both positions dA sin theta will be there, sir?
That's slip. But in this, which will
Sir,
cancel?
nothing will get cancelled, sir. They will get added, sir.
Really? Look at this.
Really, sir.
Look, this is like this. It is like this later. So these two will cancel. These two will add up. These two will cancel. No. So now d cos theta will remain.
Yes, sir.
Look, children, if I took this one, it is like this. If I took that one, it is like that. Isn't it?
Yes, sir.
If you follow the math, you need not do this. Try to understand. You can simply this and this you need to integrate. By mistake, if you say this is not becoming zero, you'll be in trouble. You have to check both. You need not even take the other side. Do you follow? Come on, children.
Yes, sir.
Speak to me. My point is, you couldn't have followed it, that old question, blindly. You should have integrated d sin theta separately, d cos theta separately, and you need not bother about which is cancelling or not. Automatically, that will tell you. Now, that means I'll only integrate d cos theta and later double it.
Okay, sir.
Rishita?
Yes, sir.
So E due to plus in the x direction will be integral d cos theta. Is it all right, children? Are we going wrong?
Yes, sir. It is correct, sir.
You should be confidently saying that's correct. Otherwise, it won't work. All right. Now tell me, dE will be what? K dq by r square cos theta. So it will be K dq is lambda not cos 2 theta. All right. R
Yes.
d theta, then cos theta by,
R square.
is everything correct calculation wise?
Yes, sir.
So when R goes K lambda naught by R, what am I getting?
Cos 2 theta, cos theta, d theta.
From 0 to pi by 2. If I am taking only this one, if I take full also, I can still do. But 0 to pi, if you will get the double the answer. That's left to you. You can check it if you want. So what do with this?
Sir, cos 2 theta as 2 cos square theta minus 1, sir. Cos 2 theta. Hello, sir. Hello.
I'm listening.
Sir, cos 2 theta is 2 cos square theta minus 1.
2 cos square theta minus 1. If you do, you'll get it. Yeah. Because that will be
One will be cos cube theta and a cos theta.
Yeah. But cos cube theta will write in terms of cos 3a.
Sir, no need na, sir. We can do substitution.
That's left to you. It all depends on your capacity for integration.
Sir, cos square theta we can take, sir.
That's left to you. Well done. I have no problem. That is your job, basically, right?
Yes.
So simplify it further. I'll go for the next question. Okay, do it later.
Sir, cos cube theta is sin x minus sin cube theta by 3.
That will be for sin 3a. This is cos 3a will be different. That's why I was asking you.
Sir, cos cube theta, na, sir. Integration.
Cos cube theta.
Sin theta minus sin cube theta by 3. Sorry, sin cube theta by 3. That's it, sir.
Okay, then you complete it for yourself. Okay.
Okay, sir.
Then I'll go for the next question. You know what to do? 0 to pi by 2, if you did, you double it. All right.
Okay, sir.
I'll just introduce the new kind of a question. Right.
So
Yes.
I did not get how to integrate cos cube theta.
You know the formula for cos 3a?
Yes, sir.
From that,
Oh,
you
we
get
should
cos.
use that.
Yes.
Oh, okay, sir. Okay.
All right. Just let's see what now. No, I don't want to kill the time only with the calculation. I want you to type. Now, look at these questions. Few questions. Different questions I'll give you. I'm giving 51 from H.C. Verma. If you have the book, look at it. Otherwise, just listen to me. This is mass M. There is an E applied like this. Charge is Q for this block. This is a smooth horizontal table. The spring constant of this is K. Find the amplitude of the resulting SHM in the block. Block was like this with a spring attached to it. E was applied like this. When E is applied, find the amplitude. Find the amplitude of the resulting SHM. That is 51 question in H.C. Verma. Oh, every time. Yeah, we'll finish this. So now a different thing we are entering in, because we did not do many questions like this. Any idea? This all depends on what you've been doing
Sir,
in your mechanics in the,
sir,
yeah.
sir, we can do EQ equal to KX now, sir, both forces.
EQ equals kx. What do you mean by doing EQ equals kx, Bharat?
Sir, force of this
Tell me where,
KX.
where? Now you applied E here like that. You mean the spring gets extended? Huh? And somewhere here you are writing that.
Yes, sir.
Huh? So this was my initial position, children. So let's analyze the question, Bharat. Don't say something like that. Huh?
Okay, sir.
So this will be EQ force like this. So from here it got extended by x. So this will be kx. So after this you tell me. EQ equals kx.
KX equals to EQ, sir.
How? Why? On what basis?
Sir,
Where is EQ equals kx? Nowhere. Only at one place the net force will be zero. In a harmonic, simple harmonic motion like this, where is EQ equals kx? You tell me. Look, EQ is constant here because E is constant, Q is constant. So because of this, it gets extended. So kx will try to oppose it. Huh? Kx will try to oppose it. So what will happen? EQ will further move it up, forward, forward, forward like that. So kx also keeps increasing. So somewhere EQ minus kx will be zero. But after that, I want you to discuss the question, not just simply say something or the other. Don't look at the answer. You'll connect it in a very bad way.
sir.
In a simple harmonic motion, every time you need to find out where is the equilibrium position, where the net force is zero. Then you'll easily
Okay,
able to calculate the amplitude. I'm discussing it. You're not listening, children. This was the undisplaced, undisturbed position. This one. So the moment EQ acted, it was accelerated forward, but kx opposite it, but still it will move forward, forward, forward. Somewhere here, for example, you will develop such a spring force that net force becomes zero. But with the block,
Sir, at time both forces will be equal now, sir.
where? Here.
When there, sir.
Somewhere. After that, what will happen to the block? Will go back?
Sir, again it will go back and come to the same position, sir. It will oscillate like that.
What do you mean to say is, here you mean to say the net force is zero, the body will stop.
Again it will come back. Sir, I didn't understood, sir. What are you saying?
I'm speaking, you're not listening. EQ, it will
Okay,
move
sir.
forward. KX will oppose it. Somewhere KX becomes equal to EQ, it will stop, you mean to say? No. It is
But
accelerating.
somewhere EQ will become zero.
This net force will be zero. This will be the equilibrium position. But the body still has a velocity. It will continue.
Okay, sir.
Will it continue or not? You tell me. This is what you need to understand now. My point is, once it pushed there, you mean to say it will go there, come here and go there, or what? What is happening? You tell me.
Sir, no, sir, it won't go, sir.
Will the block stop here?
It will stop, sir.
Here. And from there it comes
Sir,
here.
sir, it will have velocity, sir.
You need to tell me now. I think this is a problem you had in your first year, basically. In a simple harmonic motion, I want you to find out a position where the net force is zero. Where is that position I'm asking? Is it this one? This is the net position? Position where the net force is zero, or this is one? What? Where is that amplitude? I want you to tell me. No, Bharat was saying like this. It will go here and go there. Is this a correct statement or something else? Okay, I think I need to close. Just think about the question. I'll discuss more questions next time on Monday. Tomorrow, teachers' day holiday. Actually, Sunday is anyway holiday. Monday, try as many sums as possible from H.C. Verma. If potential idea is there, leave it. Otherwise, try all the questions. I will discuss it in a big way. Actually, this discussion takes a lot of time. There are two ways of doing it: energy conservation and as well force idea. Okay, so it takes time. That we'll discuss on Monday. All right.
Sir, energy conservation means mechanical energy formula, sir.
Yeah.
Conservative, non-conservative equals to Kf minus K. That only, sir.
Yeah, that one. Huh?
Okay,
But
sir.
even that you're not telling in a proper way. Huh? Okay. Let us see it on Monday. And I told you already, just have your HC Verma next time, and I'll discuss sums here and there. There are good number of sums everywhere. I'll take random sums, but good sums in the middle, and then discuss them.
Sir, tomorrow exam, sir.
Not tomorrow. We'll see. I have to do some more. Otherwise, there's no point of conducting exam. You remember, I won't give easy questions. Do you know? Hello.
Sir.
We'll have next week because we need to finish at least problems from here and then exam. I'll give you. I'll
Okay,
send you
sir.
an assignment after doing that exam. No, not for the sake of exam. Okay. All right.
Thank you, sir.
I'll end the show right now.